In this video, we will learn what the ACL wildcard masks are and how they are used. We will also discuss the differences and similarities between wildcard masks and subnet masks. Wildcard masks are used to define criteria in ACL statements. Wildcard masks allow an administrator to define a single IP address or a range of IP addresses. Without wildcard masks, you have to create an entry for each IP address. With wildcard masks, you can create a range of IP addresses that need the same actions. Let's take an example. A subnet includes 75 IP addresses. From these IP addresses, you want to block 50 IP addresses. Without wildcard masks, you have to create 50 entries to block these IP addresses. With wildcard masks, you can create a range that includes these IP addresses. Later, you can use this range to define criteria in the entry. This way, you can block or allow a range of IP addresses with a single entry. Both wildcard masks and subnet masks are used with IP addresses. They look similar, but they are different, and are used for completely different purposes. A subnet mask is used to separate the network address from the host address in an IP address. A wildcard mask is used to define the part of the IP address that you want to match in the ACL statement. Both the wildcard mask and the subnet mask have a length of 32 bits. A bit has two states, on and off. In binary, the on state is written as 1, and the off state is written as 0. In the subnet mask, an on bit represents the network bit while the off bit represents the host bit. In the wildcard mask, an on bit represents the bit you want to match while the off bit represents the bit you want to ignore. In a subnet mask, an on bit represents the network bit, and an off bit represents the host bit, while, in a wildcard mask, an on bit represents the bit to ignore, and an off bit represents the bit to match. By using an opposite bit at each location, you can easily convert a wildcard mask to the subnet mask and a subnet mask to the wildcard mask. This process is much easier than it looks. To create a wildcard mask for a subnet, all you need to do is reverse the value of the subnet mask. If the subnet mask contains the value 1, then use the value 0 in the wildcard mask. If the subnet mask contains the value 0, then use the value 1 in the wildcard mask. Let's take an example. The following address represents a subnet. This subnet includes the IP addresses from 10.0.0.0 to 10.255.255.255. To create an ACL statement that matches this subnet, we have to use a wildcard mask that ignores all network bits but matches all host bits of the subnet address. To ignore all network bits in the wildcard mask, we have to use the value 1 at the place of each network bit, while, to match all host bits, we have to use the value 0 at the place of each host bit. Let's take some more examples. In this subnet mask, we have all ones in the first byte. So we will put all zeros in the first byte of the wildcard mask. In this subnet mask, we have all ones in the first and second bytes. So we place zeros in the first and second bytes of the wildcard mask. Same way, in this subnet mask, we have ones at the first 24 places. So we will change the first 24 bits to 0 in the wildcard mask. If you have subnet masks in decimal and want to create wildcard masks for them, you do not need to convert them into binary. Creating wildcard masks in decimal is also easy. To create a wildcard mask for a given subnet mask, subtract the value of each byte from 255. Let's take an example. Suppose you want to create a wildcard mask for the subnet mask 255.255.0.0. If we subtract each byte of this subnet mask from 255, we will get the wildcard mask for this subnet mask. Let's take some more examples. In the first example, if we subtract 255 from 255, we get 0. Therefore, we will put 0 in the first byte. If we subtract 240 from 255, we get 15. Hence, we will write 15 here. For the third and fourth bytes, if we subtract 0 from 255, we get 255. Therefore, we will write 255 in the third and fourth bytes of the wildcard mask. In the second example, 255 minus 255 equal to 0. So, we will write 0 here. And here. In the third byte of the subnet mask, we have the value 16. If we subtract 16 from 255, we get 239. Therefore, we will write 239 in the third byte of the wildcard mask. 255 minus 0 equals 255. So, we will write 255 in the fourth byte. In the third example, if we subtract 255 from 255, we get 0. Therefore, we will write 0 in the first, second, and third bytes. In the fourth byte of the subnet mask, we have the value 128. If we subtract 128 from 255, we get 127. So, we will write 127 in the fourth byte of the wildcard mask. ACL statements use wildcard masks to define criteria. To identify which statement filters which address or address range, you need to calculate the subnet mask from the wildcard mask used in the statement. To calculate the subnet mask in binary, use the opposite bit at each place. For example, if you have 1 in the wildcard mask, use the 0 in the subnet mask. Or if you have 0 in the wildcard mask, use the 1 in the subnet mask. Let's take some examples. To convert this wildcard mask into the subnet mask, change these zeros and ones. And these ones and zeros. In this example, change these zeros and ones. And these ones and zeros. In this last example, we need to change these zeros and ones. And these zeros and ones. To calculate the subnet mask in decimal, subtract each byte of the wildcard mask from 255. For example, if we have 239 in a byte of the wildcard mask, we will use 16 in the byte of the subnet mask. Because, if we subtract 239 from 255, we get 16. Let's take some examples. 255 minus 0 equals 255. 255 minus 15 equals 240. 255 minus 255 equals 0. If we subtract 0 from 255, we get 255. So, we will write 255 here. And here. 255 minus 239 equals 16. Therefore, we will write 16 in this byte. 255 minus 255 equals 0. 255 minus 0 equals 255. Hence, we will write 255 here. Here. And here. If we subtract 127 from 255, we get 128. So, we will write 128 here. There are two special wildcard masks, 0.0.0.0 and 255.255.255.255. A wildcard mask of 0.0.0.0 instructs the router to match all 32 bits of the address. This wildcard mask is called a host mask. This wildcard mask is used to match a single host. For example, if you want to allow or deny a specific host from a segment, you can use this wildcard mask to match the IP address of that host. The following statement shows how this wildcard mask is used. The above statement will deny only the packets that are originated from the host 10.0.0.1. A wildcard mask of 255.255.255.255 instructs the router to ignore all 32 bits of the address and match all packets. This wildcard mask is used to match all packets. Since this wildcard mask matches all packets, the IP address that you enter with this mask does not matter. Technically, you can enter this wildcard mask with any IP address, but usually, it is used with the IP address 0.0.0.0. Administrators use the following IP address and wildcard mask to match all incoming or outgoing packets. That's all for this video. This video is the 5th video of the video tutorial series Cisco Access Lists Explained with Examples. Thanks for watching this video.